In this video, we will learn to build a task management application and learn the basics of composition, reactivity with signals, computed signals, dynamic interfaces, user interactions, events, control flow statements, dependency injection, services, state, component level state, service state, inputs, outputs, models, and much more. Remember, it's not the size of the application, but the concepts that we cover during this time. If you are looking to have a quick overview of Angular in a short period of time, this is the video for you. Let's start by scaffolding a new Angular 19 application from scratch. If you are new and need help for that, do watch the first 3 minutes of this video where I discuss in detail the prerequisites, node installation, and Angular CLI installation. To make our life easy, I have already made the HTMLs upfront using Bootstrap. Check out the description for the GitHub repo details. Now, assuming you are done till this point, let's move to the next section, which is designing the application and scaffolding the components upfront. Let's have a quick walkthrough of the application which we are going to build. This is a small task management application where we have a navbar, a status bar which shows the number of tasks in each status, a list which shows the details of the status. Selecting the list will open up a panel for updating the task, and the state for the same is done and kept in sync using signals. We can also add new task using the same panel, and towards the end of the video I'll also add a couple of fun challenges for those who want to take this one step forward and build on top of this. When it comes to designing the application, this is a rough outline of what I have in my mind. We need a navbar component, a status bar component, a task list component, and once the application is working as a part of refactoring, maybe I can split the list into individual items so that we keep the list and the component clean. We need a modify status panel because the same panel needs to be shown for add as well as update. And as far as state is concerned, we need to hold a task or a list of tasks. When it comes to the question of where should I hold this state, the first question that I ask is this something particular to a component, or is this something that needs to be shared around and kept in sync? If the answer is the latter one, that is an indication that we need to keep that state slice out of the component and possibly towards services which hold non-UI logic and can be injected into multiple components and kept in sync throughout the app. We also need a current selected task based on which we can update the respective task, and an ease panel open based on which we can toggle the visibility of this panel. Now, these two can be component level state. I don't need to hold them in a service. Defining the state is an iterative process where we start at some point, and as and when the application grows or needs changes, we refine and refactor. So consider these as an outline only. Changes can happen as we start building. Before starting, I just cleared the app component.html, put a hello world message, and ran npm start and checked the browser as well as console to see if there are any errors. Since there is none, we are good to go ahead and start scaffolding the components. Let me switch to a bigger terminal, run this command and see the output, and then I will explain what this command means. So let me trigger the command, go back to the editor and see the folder structure and the components that is getting generated. It automatically scaffolded the components folder, and within that, navbar, status bar, status panel, task list, service folder within which I need a service. So everything else is scaffolded using Angular CLI itself. Now coming back to the command. NGGC means NG, hey Angular CLI, generate a component within the app folder. So within the app folder, create a components folder within which go ahead and create a navbar component, which is what we are seeing here. Skip import basically means it creates the component, but it doesn't register the component anywhere. It's up to us to manually register based on where we are going to use this selector. Similarly, skip test basically says do not add test cases at this point. So it will create a .spec file otherwise. Since we are not going to write test cases in this video, I don't want unnecessary files lying around. So I just wanted to omit all the spec files for the time being. Similarly, the other components, status bar, task list, status panel, and when it comes to services, I say ng generate a service, create a services folder, which is what we are seeing here, and within that create a task service, and that is what we have here. Also, do not generate the spec file for this particular service. All we need is just the TS file. My personal choice is to start with the service layer. It's not a rule, but partly because of the habit and partly because of trying to knock the harder things first. The moment service layer is up and we also have the model that defines the structure of the data, it becomes way more easier to start bringing them into the component and consume them. Every application needs data. And since we are not having any API calls behind the scenes to fetch these data, let's have a folder called data. And within this, have a file called index.ts. And do export const task data equal to an array. Let me paste in some predefined values so that we have something to begin with. This is nothing but an object that contains ID, task, status, and assign to. So these are the 4 properties. Let's do one more thing. Let's add a model and name it as task.model.ts. Within the task.model.ts, we define an interface. So export interface task. And just to confirm, let's open the task and split it down so that we have a reference here. And based on the structure here, ID is a number or string. Task is a string. Status is a string. Assigned to is a string. We define the interfaces because when we are consuming the data via a service, we exactly need to be sure about the shape and the structure of the data we are consuming. And also when it comes to having intelligence, the moment we put a dot, we need to know what properties are available so that it reduces the number of runtime errors trying to access something which isn't defined on the object. Coming back to the services, let's close the index.ts and the task.model.ts and focus on the service. End of the day, a service is just a class. So if you take out the injectable decorator and the import, this is just a class. A class when decorated with @component becomes a component, and a class when decorated with @injectable, this becomes a service. Now the injectable decorator, just like the @component needed a metadata, this also needs a metadata which accepts a property called provided in, So we have root, platform, any as the valid options, but we choose root because this option registers the service at the root level of the component hierarchy, thus making it a singleton, and any component within the hierarchy can inject the service to consume whatever it exposes. Framework guarantees that only one single instance is created and shared around. And so, whichever component consumes the data, they know that the other components too are consuming the same instance of service, thus making it easier to share data and keep them in sync. Enough of the theories and coming back to the code. Let's start by defining a task state. So, task equal to what? For me, this is not a property. I want this to be a signal because end of the day, signals are containers. It's not just a property, but that property wrapped in a container. The benefit being the moment you use this container anywhere in the application, whenever the value changes, that container is kept in sync. So let's define the signal which needs to be imported from the at angular / core. Signals always need an initial value, which is where we need to bring in our task data. And just to define the shape of the signal explicitly, I'm saying task, which is what we defined in our model, and an array. Since I don't want anyone to start accessing this signal from anywhere in the application, let me make it private by putting a hash, and let me define a method called get all task. This returns this dot task dot as read only. So instead of returning a signal that can be overwritten from anywhere, I'm making it read only so that none of the components are able to write the values into the signal, but they can only consume the signal. And just to make it explicit that this returns a signal of type task array. This is a decent start for our service. Coming back to the UI part, let's start by adding a Bootstrap theme. In the index.html, let me paste a Bootstrap theme. If you go to bootswatch.com, links to the same would be available in the description. You will get a lot of Bootstrap themes. Since I'm very much bored about the usual Bootstrap look and feel, I just wanted something different. That's why I chose one from this set of options, something called Cyborg, which is a black theme. Now that I have introduced the Bootstrap theme, you can see that it instantly took effect and everything became a black theme. Before I forget, let me add a small margin here, class m-2, so that there is some margin at the edge of the design. Let's fill in the templates first. Let's go to the components, navbar, navbar.component.html, and let's fill in the navbar. Take the navbar component and register the same within the app.component.ts imports. Let's use this here and go to the app.component.html. Replace this text with app-navbar. And now we can see that the navbar is ready. Similarly, let's also fill in the next component, which is status bar. Let me paste the HTML for the status bar. This is just pure HTML and CSS. There is nothing Angular about it. This also comes with some styles. Now, if I want, I could have placed it within the styles.css to make it global. But then since this style is very specific to this component, let it be part of the components CSS here. Now that we have here, let's also fill in the task list component. Let's paste in the HTML for the task list and also its corresponding styles. Now all we need is to register these two components. Let's go to the app.component.ts, register the status bar component as well as task list component, and use the selector we already see our navbar, status bar as well as the list. When it comes to injecting the service, where should we put them? Now that we have the task.service.ts and calling the getAllTask method will return the task, although in a read-only way. Still, where should we put them? Should I dependency inject the same in the task list component and consume here itself? Or should I dependency inject the same in the app.component.ts since we have the app task list as a child in this template? We could go this way and pass an input property into this component and then pass the value down. That's also possible. But personally, I'm not a fan of passing unnecessary inputs to the component just for the sake of it. My choice is to hold the state at a component who actually needs them. And if one of the sibling components also need the same state, then lift the state up to its parent and then pass the data into both components. This technique is called lifting state. Let's bring in the task service. So task service equal to, let's dependency inject task service, and let's create a property called task and call the task service dot get all task. If you hover the task, we know that this returns a signal, and signals need to be unwrapped within the templates. Let's go to the template. Right now, this is a static piece of content. So let's take this piece out and let's use a control flow syntax for looping, which is called @for. This is an Angular specific syntax, and all we need is to loop over the collection and display a list item for each instance in that collection. The syntax is, you can name it whatever you want. I'm naming it as task of task. So this was a signal and we need to invoke the signal to unwrap it, and as a dependency for loop, we also need to pass a track so that this loop can be identified uniquely using something, and that something is task.id. This is a part of performance optimization from the framework. Whenever we are looping over a collection, we need to pass something to identify each instance uniquely. Here we are passing an ID because we know that for each object in that collection, there is a unique ID. So we use interpolation, and the moment we put that dot, we get that IntelliSense. That happens partly because of the language service of the IDE as well as our models. We need the task, and the status comes from task.status. Now if I save it, we can see that we have our task along with the corresponding statuses here. Since I need the statuses to highlight with certain color based on whether it's on done, progress or not started, let me go to the task list component.ts, write a method called get task status. This will accept a status which is string, and let's return if the status equal to done, then return done, or else status equal to in progress. If it is so, then return in hyphen progress, or else return not started. These are the corresponding classes which we have here, the done, in progress, and not started. And to bind this, let's go to the template. Let's attach the class using a property binding for the class. Call the get task status and pass in the task dot status. The moment we do that, we can see on the side the respective colors has been applied to the respective statuses. Now let's add a click listener to the list item. Change status and then pass the task into it. Since this method is not implemented in the TypeScript file, the IDE is complaining, so let's go ahead and do that. We receive a task which is of type task. Let's do console.log of that task. Let's clear the console and try selecting the individual task and see that yes, we are able to see the individual consoles with the respective task. Next, let's move towards the status panel, for which let's go to the status panel component.html, remove the text there and paste in the template. Take the status panel component and register the same in the app.component.ts. Import the same, and once we have imported, let's bring in the selector so that we can see the panel. As of now, it's totally static, but that's okay. We'll eventually fill it. The next step is that whenever we select here, we need to take this and pass it to the app component so that based on the selection, we can update this panel here. So let's add an output to the list component. Let's go to the task list. Let's create an output on status select equal to output. And to be very specific, I'm saying this output would be of type task. And whenever this change status is triggered, please emit this particular event emitter with the task. And let's remove the console here. Since we know that this particular event is getting emitted, let's go to the app.component.html and let's listen to the on status select, handle that, handle status select, and what I get is been caught in the $event. Let's go to the app.component.ts and implement the handle select. Let's receive the task which is of type task, and let's first console.log from parent. Now if everything works as expected, The moment I select one of these list items, it should show the same in the console, but this time being handled at the parent level. So we can see that the console is working and the functionality for passing the value from child to the parent via an output is been hooked up. If you are confused at this point as to what this output is all about, here is the explanation. In component-based architectures, may it be Angular, React, Vue, whatever, there is a concept of unidirectional pattern, wherein data flows down and even flows up the hierarchy tree. Since we restrict the data flow only in one way, it becomes way more easier to reason about the application. If something changes or breaks, we know where to pinpoint because the state change is happening at the parent level. Chances are mistake might be on that level too. After all, child is like a projector. Whatever passed to it from parent is being displayed, and whenever it needs to let the parent know of something, it emits an event. Since we already have access to the selected task here, let's create a current selected task equal to, make it a signal, and I know that this will either have a task or this might be null. And since every signal needs an initial value, let me pass a value of null. And since we have the task here, let's set the value for the current selected task by calling set and passing it a task. To toggle the visibility of this panel, I need to have one more slice of state. So let's do is panel visible, and instead of making this a regular property, I'm going to make it a computed property. So a computed property is a property that relies on another signal's value. So whenever this changes, this property would be kept in sync. So let me use this dot current selected task. If I invoke it, not equal to null. So if it is null, this should be false. If it is not null, then it means that some selection is there. So we should show the panel. Let's take this property, go to the app.component.html, put a control flow syntax for if, and since this is a signal property, let's invoke it and let's pass this app status panel into the if condition. So if I refresh the application, right now there is no panel. The moment I select, I can see that the panel visibility is there. The next step is to pass the selected task into the app status panel. This is where we need to use the input to pass the data from the parent to the child. Let's first set up the panel component to receive the input and wire up its templates. So let's go to the panel statuspanel.component.ts. Let's have a task equal to an input. So we will be passing a property called task, and this input will be of type task or null. Now that we have the task signal property here, let's go to the HTML and bind the current task. Since task is a signal, invoke it and then call task on it. And let's also bind the value of the select dropdown to task dot status. And since there is a possibility of null, we need to use the question mark to short circuit so that if this is undefined, then this will not throw an error. Just to check the logic, let's take the task, go back to the app.component.html, take the task and pass the current selected task as the input, invoke it so that it passes the value. Refresh, and the moment I click this, yes, I can see the current task, which is this one, and its corresponding value in the drop down here. So if I select this one, it is a done. If it is this one, it's not started. If it is this one, yeah, so not started. So currently the panel is in sync with whatever we are selecting at the top of the list. The next functionality is to wire up this update button, as to when we change the status and click on update, it should be updated and reflected in the list. Let's head back to the service, task service. Let's create an update task method. This accepts an ID, which is a number, and the status, which is of type string. And let's create task equal to this dot task. Since it's a signal, invoke it. Let's map through it. For each item, return if t.id, so individual task.id is equal to the id which is passed. If so, then let's spread the current properties and then change the status to whatever which is passed from the outside. Else just return the task as is. And once this mapping thing is done, we need to update the signal. So this dot task dot set and pass in the task. Since we are here, let's wire up the add task also. Add new task. The input to this is the task, which is a string, and const current total. Since we need an ID, let's do this dot task dot length. Since this is an add functionality and we need to take into consideration the existing ones also, we have one more method called update, not just set. So let's do this dot task dot update, which will give us the current value of the task. And let's return an array, spread the current ones, and then let's add one more new item whose ID is current total plus 1, assigned to, for the time being, let me provide me task. Let's pass in the task which we received from outside, and status is not started. And just noticed a typo here. Let's make it caps. Now let's head back to the StatusPanel.component.ts. We have our update button. So let's have a click, update status, and let's pass the task. Let's wire up the update status method here. We receive the task, which is of type task. Let's inject the service. And within the update status, this dot task service dot update task, and we need to pass the ID as well as the status. Before proceeding with this one, I just noticed a small mistake. We don't need to pass the task again from the template since that is already available within the class. So let's take the parameter out of this method so that both template as well as class is happy. For the update task, we need two things. One, the ID as well as two, the status. ID is easy, we'll get it from the task. So let's say const task equal to this dot task, and I'm saying that okay, don't worry about task being undefined, I'll take care of it. So you just assume that there would be a task, and let's do task dot id. So the id is ready. Now for the status, we need to go to the select, have a change, handle select change, and then pass the $event. Let's handle this method within our class. We receive. For the time being, let me just put any. I'll change it and refactor it a bit later. Let me have new status equal to an empty string, and whenever it changes, this dot new status equal to event dot target dot value. Now all that is left is to pass the status as the second parameter here. So let's do this dot new status. It says type string is not assignable to type number. Okay, so let's put a plus here so that we change the type to a number. And now the application is happy. And to test the change, let's select an in progress task, which is this one. Let's change the in progress to done and hit on update, and we can see that the status has updated from in progress to done in the main list. So the functionality of updating the status is also working. The next step is to wire up this status bar. As of now, this is totally static. There is nothing angularish about it. So let's wire up the status to reflect the actual number of in progress, done, and not started task. For that, let's go back to our service, and inside this service, let me create a private method, private filter task, which accepts a status which is of type string, and this return this dot task dot filter for each task t dot status is equal to the status. So basically what I want is all the status corresponding to done, progress, and not started individually. So I create a private method so that I can call this method, pass the status, and get the actual number of items. Let's also create one more public method. Get computed task status, and I'm going to make it computed so that whenever the actual task signal changes, this would be in turn reflected with the updated values. Let me return a custom object with done pointing to this dot filter task corresponding to done. All I need to know is the length of it. Let me copy this, paste it twice, and this corresponds to not started and node underscore started, and this is in progress, and the filter task string value should be in underscore progress. Just a small correction here. I believe I said we are going to create a public method, but this is not a method, it's a computed property. Just a small slip from the tongue. Now that we have the computed property here, all we need is to go to the status bar, inject the service, let's put a property called status and point to this dot task service dot get computed task status. Now that we have the property here, let's go to the HTML, and instead of the hard-coded values here, let's do status, which is a signal. So let's invoke it dot done. Let me copy this piece and paste it to status dot in progress and status dot not started. There is a small typo here in the service. I believe it's in progress, not is progress. So let's make the corresponding change here also, in progress. And if we refresh the application, we can already see that in progress is 1, done is 1, not started is 2. So if I select one of the not started, change it to done, and the moment if I update, the number changed here and one got subtracted from here. So the logic for the status bar is also working fine. The next step is to add a button called add task. The question is, where should I put it? Shall I put it in the app component, or shall I put it in the task list component, or somewhere else? Since the logic to show the panel lies at the app component level, the easier option is to put the button at the app component level itself. So let's go to the app component.html, and right at the top of the list, let's put a button. And since upon clicking the button, we need to show the panel, let's wire up the add new task here. But when we do so, we will encounter a small problem. It's not actually a problem, but since the needs changes, refactoring becomes essential. With the add new task, what will we write here so that we can toggle the panel for updates as well as add? We need to show the panel, but the logic for the panel visibility currently depends on a computed signal, which in turn depends on a current selected task, which is another signal, and that signal is either null or a task. If we do not select anything, it's null, and so it's hidden. Unless we select something, it's anyways null. So bottom line, this logic needs to be tweaked. Sometimes the solutions are much simpler than we think, or putting it in another way, we made it complex than it actually needed to be. I initially thought of re-recording the portion with the next solution, but hey, it's coding. Things will evolve, things will change, and getting everything right at the first time itself may not be possible. But the point is, get them right eventually. And the simple solution here is to change this from a computed signal to a regular property. So I assigned this to false, and whenever somebody updates the status, I flip this value to true. Let me copy these two. The only difference being, when we are in the add mode, we can set the current selected task to null, and is panel visible will still be true. And the only change we need to make is to change this from a signal to a regular property. Now, just to check if our logic is right or not, let's click on the add new task. The panel becomes visible. Refresh it once again and select a task. Now also the panel is visible. So the visibility is showing right for both add as well as the update. The difference being, based on the mode, we need to show a different UI here, which is what we are going to do next. Let's move to the status panel component, within which, based on whether we get a task or not, we need to be either in the update mode or in the add mode. If we get a null, we are in the add mode. If we get a task, we are in the update mode. So keeping that logic, let's do is update mode equal to, put a computed property, and then see if there is a task. And just to make it a boolean, let's do double exclamations. So this will always give me a signal of boolean, which is what we see here. I always get a signal of boolean. Now let's take this is update mode here to the HTML template, and let's have a logic here. If we are in the is update mode, then the text should be update task, or else it should be add task. Similarly, if we are in the is update mode, then we show this particular HTML. Or let's have an else clause. Let's put another set of HTML. So all we have is an input and a button so that we can add new task into it. Just to see if the logic is working fine, let me refresh. Let's click a list item. So we see that we can see the update task, which is what the logic says. And now if we click on add new task, we see a different UI. Based on the logic, we switch between add and update mode. And to wire up the functionality when we click on this add button, let's put an input ref. Have a click event and wire it to on add, which is a method that we are just going to add. This gives us reference to the input element as is. We just need the value from that. Let's take this on add and implement the same. Here we get a task, which is a string, and all we need to do is this dot task service dot add new task and pass the task. The logic for the add new task was already written some time ago within the service. Let's check if the logic is working or not. Let's click on add new task. And click on it. Now we see that the new items are getting added to the list. The current status is not started. Let's try switching it to done. And the moment we update, we see that the number has increased. So the logic for add task is working fine. Now the only small functionality that is missing is that when I click on this X into mark, I need to close this panel. For that, let's go back to the statusPanel.component.html, and on the span here, let's wire up a click event handler and wire it to on close. Let's wire the on close method here, and all we need is to have on status close equal to an output. We need to let the parent know that, hey, somebody clicked the close button. Please go ahead and trigger the logic. So within the on close, let's do this dot on status close dot emit, so that we trigger the event emitter from the status panel component. Now somebody needs to grab this event, and that somebody is the app.component.html, within which let's listen to the on status close, and let's write a method called handle close. Within the handle close, let's copy this logic, the only difference being flip this to false. Just to check the functionality, add, close, update, close. So this functionality too is working. As far as this small application is concerned, that's all we had to do. But the bigger point is, pause the video for a minute and ask if you are able to understand and articulate the following concepts on screen that were used in the application. If yes, well and good. If no, that is an opportunity to brush up on those concepts once again. Just out of curiosity, I'm going to put my code for review, this time with AI. Since I have Cursor AI, I just wanted to see if that can provide some suggestions or improvements on top of what we wrote. Sometimes one more eye to look at what we wrote is always good. Keep in mind, I'm not asking AI to code for me, but I am just using AI to review my code. I pointed the code base and asked, hey, please go through the application and suggest if there are areas of improvement in terms of best practices, state management, or better alternatives or approaches to what I wrote. Consider yourself as an Angular architect and you are doing a code review, and I took the best possible option, which is Cloud 3.7 at this point, and let's see what it comes up with. It gave us a lot of suggestions, of which let's see what all are the most important ones. Standalone components configuration. Your components are using the standalone API, but I noticed that you are missing the standalone true. That's okay, because since we are using Angular 19, even if we don't use standalone to true, it's still taken as standalone. So although the suggestion is fine, but this is unwanted. State management improvements. Use a more robust state management pattern. What's the suggestion here? These are suggesting slightly better ways of writing our task service. So they renamed it as task store, but most of the logic which we have stays as is. So we are good at this point. Type safety improvements, yes, I mentioned about using any and then changing. The review had actually caught it, which is fine, and it's even suggesting the possible options which we can use here, which is even better. Task ID type consistency, yes. I initially wrote as number or string, but then we are only using the number, so it figured out that string is basically not needed, so we can take it out if we want. That's fine. Task status can be moved to an enum or a type. That too is fine, since we are only having 3 possible options: done, in progress, and not started. We can move that into a specific type. That's fine. Component communication. Instead of using outputs for simple state changes, consider using a service with observables. I don't want to move much towards observable because I wanted to use signal based solution specifically. So the suggestion is fine, but as of now, I'm good with what I have. Form handling. All right. So this is suggesting that if we want, we can use form builder, um, which is okay. I didn't want to make the application more complex than it need to be. Avoiding forms at this point was intentional. So that's okay. Performance optimization. On push change reduction. For better performance, use on push change reduction. All right, that's a suggestion. I'll take it. Um, we can explicitly turn on the change reduction using the on push. That is fine. Testing, yes, not needed at this point. So let's not look into that. Routing, yes, I didn't want to introduce a route, but I'll take that suggestion. Error handling, since there is no API calls involved, actually there is no need for error handling at this point. But yes, if we are making an API call to fetch the task, then yes, we need to consider the error handling for that. Accessibility improvements, all right. So since we are using Bootstrap code, my understanding was it's already accessibility compliant, but still, whatever more, I'll take it. So that was the in general suggestions provided by Cursor AI. A good amount of that, yes, I can take it if I'm building a more bigger application. So that's how I evaluate my own code at this point. As promised, here is a fun challenge. It's up to you to implement them or not. In the task data array, there is an assigned to property. You can write the logic to make sure that only those tasks assigned to you can be updated. The rest you should not. That's it for this video. I hope this video was able to contribute to your knowledge. And if you had find it useful, show some support by subscribing to this tiny channel. It means a lot for me and inspire me to bring more such content. Check the ongoing Angular series if you are interested in that. Once again, thank you and bye bye.